Hi everyone, here comes the last video for this set of videos about impulse and momentum. It's number 10 and I've saved the best one for last. So here we go, back to the old school, and it goes like this. Example 3. This one is in 2 dimensions, by the way. Suppose a 1.2 kilogram mass is sitting on a frictionless table. The mass suddenly explodes into 3 pieces. M1, 0.5 kilograms, flies off at 20 degrees north of east at 3 meters per second. A second mass, M2, 0.3 kilograms, flies off at 40 degrees south of west with a speed of 5 meters per second. What are the final momentum and velocity of the third piece? Okay, so pause the video to get this written down. And then the next thing I'm going to do is I'm just going to put this up here like this and show you a little picture. Hopefully you can see that. Okay, so let's see. I'll do this. There we go. Try this. Okay, so we've got a mass up there. That's mass 1. It's flying off at 20 degrees north of east. And then down here we have mass 2. It's flying off at 40 degrees south of west. Okay, so take a look at that and write that information down. I know this is not the greatest way of doing things, but it's kind of all I know for now. Okay, so get that written down and we'll talk about it. So let's see what we got here. We've got one mass that explodes into 3 pieces, and we're given information about 2 of the pieces, and we have to find information on the third one. And I'll just start off with an equation, and it looks like this. Pull that in a bit. Can we see that? Yes, we can. Okay, so this is explosions in 2 dimensions. And as usual, we know that the total initial momentum will equal the total final momentum. Now, the total initial momentum, the mass is just sitting there, not moving. So that way we conclude that the total initial momentum is 0. And the 3 pieces, you add all their momenta up, and you will equal 0. So that's kind of strange, adding 3 things up and you get 0. Well, we know that that's possible. So we know all the information about mass 1. It's flying 20 degrees north of east. We know the information about mass 2. It's flying 40 degrees south of west. And we need to find out the information on mass number 3. So what we'll do is we'll set mass number 3 all by itself, and then we'll come to some conclusions on what to do next. Okay, this will probably take 2 boards to fill and about 10 minutes from now to complete. So here we go. We have 0 is equal to P1F plus P2F plus P3F. I want to get P3F all by itself, and so that's what I'll do. I'll take it away from both sides, and I'll end up with this. Negative P3F is equal to P1F plus P2F. Okay, so that is the fact. And once we get this one, or this expression, we just take the opposite, and that will be the momentum of mass number 3. So if you take, I'm just going to sketch out the diagram we had before, very roughly here. I'm going to go like that. That's mass 1, and that is mass 2. And I'm going to go like that and like that. That's 20 degrees. So I want to get some information. I'm going to solve these two together, and then from there I'm going to go and come to my conclusion. So let's go with M1, the first mass. We'll also make a chart over here, and I'm going to do this vector x component and y component. Okay, so I'm going to go P1F, P2F, and then finally P1F plus how's that showing up there? All right, so P1F, we're talking P1 right over here. The x component is going to be this part. That's going to be P1Fx. And P1Fx, you can see, we've done enough trigonometry to be able to see that this P1Fx is actually the cosine of 20 times P1. So the cos of 20 times P1F. And P1Fy will be the sine of 20 P1F. Now, if you look back in your original information, you are going to find out that this first mass, it has a mass of 0.5 kilograms, and it goes 3 meters per second. So P1F is actually going, we're going to go down here, cos 20 times 0.5 kilograms, 3 meters per second. I don't have room for the units. Okay, so once you plug that in, you're going to get a value of positive 1.41. Positive 1.41 kilogram meters per second. Okay, if you need to draw yourself a big triangle somewhere off to the side for both of these, then by all means go and do that. All right, so just step aside for a second. What is the momentum of this one? Well, the momentum of this one is 1.5 kilogram meters per second. It's very easy. It's 0.5 kilograms times 3 meters per second. Okay, and sine 20 times P1F is going to give us a value of positive 0.513. Positive 0.513. Now you might have to fill in the gaps for yourself, okay? I really feel like I'm going a lot faster on this example than I did on the other ones, and it's because I don't want to do any more examples because this unit has gone on long enough. Okay, what is P2F? I'm just going to write it over here. P2F. P2F. Let's see. What is the information we have about P2? Let's see. We have 0.3 at 5 meters per second. Hey, it's the same thing. So is equal to 0.3 kilograms times 5.0 meters per second. And what does that work out to? Oh, that's 1.5 again. How about that? Kilogram meters per second. So we're going to go over here and we're going to do the components of P2F. So P2F, I'm going to fill in this chart again. And notice that the cos, this is still the cos of the angle, but it's going to the left, which means we got to introduce a negative sign. So again, it's going to be negative cos 40 times 1.5 kilogram meters per second. I'll give you the answer straight away. It's negative 1.15. Negative 1.15 kilogram meters per second. And obviously this is going to be sine over here. And because it's going down, we're going to say it's negative sine 40 times 1.5, and that is going to be, let me clean that up a bit. That is going to result with, in this number, negative 0.964. Negative 0.964. So I want to take this number and add it to this number. And I want to take this number and add it to this number to give me a resultant. So 1.41 plus a negative 1.15 is going to give me, that's on the next page, positive 0.26. And over here in the y direction, we are going to have negative 0.451. Okay, so take a minute, make sure you have all that. And I will find a rag and erase this. Uh-oh, somebody must have been cleaning up my office. There we are. Sorry about that. All right, so we got that going, and I'm gonna just go like this. So what we just did was we made a chart of the components of the two pieces that we knew about. I'll rewrite those. We know that P1 plus P2F is equal to the following. In fact, I'm just going to go like this. I'm going to say, I'm going to make a triangle, and I'm going to go like this. This is going to be 0.26. And this is going to be 0.451. Okay? So, you know it's going down. That means that's where we dealt with our negative value. So here we are with the resultant of P1F and P2F. There we are right there. We're going to draw an angle in there, theta. We're going to do some basic trig. If you do some basic trig, you're going to see that this angle here, that would be the opposite. This is the adjacent. So theta, and that will be tan theta, comes from tan, and in particular we have tan theta is equal to 0.451 over 0.26, which is equal to 1.7346. We'll undo that, and we'll find out that the tan inverse of this guy is equal to very close to 60 degrees. So in our situation here, we have the following. There's our X and Y axis right there. This one is P1F plus P2F. That's what that is. And we know that this is 60 degrees. How are we doing there? Can you see that? So I'll take a couple of our resultant for getting P2F is obviously going to be up here. I'll draw it a little bit shorter, just so you know. So that's going to be 60 degrees. That'll be I meant to say P3F. So we need a magnitude for this, for P3F. So the magnitude of P3F comes from the components here and just doing a basic right triangle. So we can use this back over here for the magnitude. So what would the magnitude of this one here be? This one is P1F plus P2F. Let's just make sure everybody is seeing that okay. And that is 0.521. kilogram meters per second. So then the magnitude of P3F is going to be 0.531 as well. And the direction is going to be 60 degrees north of west. Now, we don't have the final velocity of mass number 3. So let's just write our final relationship down here. So we know that the momentum is equal to mass 3 times velocity 3 final. Now, we weren't given mass 3 directly, but if you go back into your notes, you'll see that, oh, mass 3 must have to be 0.400 kilograms. Okay, and then we have our unknown V3F. And what is the magnitude of this one over here? I'm losing my thought for a second. 531, and that's a decimal place. So the momentum of the third piece is 0.531. And we know that it's got a mass of 0.4 kilograms. So we'll solve for V3. I'll divide out the 0.4. And that is going to give us a final answer of, let's see, 1.30 kilogram meters per second, and that is V3. Oh, sorry, that's not kilogram meters per second, that's meters per second, my bad, is V3. I had to include a little bit of reality. You guys know me. So anyway, that is a fairly complicated one. And I am going to start writing up a practice set for you that's based on all these examples that I gave over the last 10 lessons. And I'm also going to just record a little intro as well. I know that doesn't make sense, but now that I've completed the series, I want to at least be able to give you a proper intro. So we're going to have a review sheet based on these 10 videos. I'll give that to you through the email. I want you to ask me for it because I have to somehow keep in contact with everybody, and that's a good way to do that. You say, hey, Joe, can I have that question page, please, or something like that. And then I'll give you that, and that will mirror a test that I'll give down the road. But I don't want to take too long for this, so I'm going to shut her down for now. Thanks for listening, and I'm missing being in class with you guys, but this is going to have to work for now. Take care.